Assalamu alaikum wa rahmatullah. Welcome to the 10th video. Well, in the last video, the ninth one, we were explaining that when the elevator falls freely under gravity, the acceleration of the elevator equals the gravitational acceleration, and for that reason, the scale records zero. The apparent weight of the man is zero. The scale here will record zero, and the man experiences weightlessness, meaning he will feel no weight at all. And this makes sense. Look at it here when we use this equation for free falling body, m into g minus a. Now, if this a is equal to g and you put g here, g minus g will be 0, and then your w will be 0, and that w will now be w3 m into g minus a, and because now a equals g, g minus g will be 0. This is why they say if the elevator descends with an acceleration a equals g, we say the lift is falling freely. This happens when the cable of the lift is cut. Under this condition, we see from equation 6.21, meaning this very equation, okay, if you take it, you can see that your W3 will be 0 because A equals G, so G minus G will be 0, okay? Okay, additionally, they say that thus the man appears to have no weight, meaning weightless. The man appears weightless. The man and the floor are exerting no forces on each other. The scale reads 0. So the man will be floating in the scale. Look at, let's go back to the diagram. As you can see, in the first one, the man is touching the floor. The man is touching the floor of the lift. This one too. But look at this one here. Look at the fourth one. The man is not even touching the floor at all. He's floating inside. Okay, because his weight is 0. He experiences weightlessness. Now, because in the material he used, there is no example at all. There is no example. We are only given equations here. In the first one, we have weight is equal to mg. In the second one, we have weight equal to m into a plus g. And then in the third one, we have weight equals m into g minus a, and finally weight equals 0. Now, we need to have an example at least, and for that I created one example. Let's see that. Weight in elevator, PHY 1201 mechanics, Shuaibu Muawiyah Silent Kanu, July 21st, 2024. Okay, here is I call it problem 1. Problem 1. Okay, I call it problem 1. A man of mass 80 kilogram. Wow, this man has weight 80 kilogram. Stands in an elevator. Calculate the man's apparent weight when the elevator A is at rest. B moves with a uniform speed of 20 meters per second. Ascends with acceleration 5 meters per second squared, descend with acceleration 4 meters per second squared, and finally when the elevator falls freely under gravity. Okay, let's see, how do we solve this problem? In the first one, remember the elevator is at rest, and going by what we explained here, when the elevator is at rest, the first scenario here, when the elevator is stationary, that's at rest, or the elevator moves with a constant velocity, the weight of the man equals mg, and that is the true weight of the man. So using that, in our solution, we can say the weight of the man equals mg, and this is equal to 80, the mass of the man, and g, acceleration due to gravity. We know that as 10 meters per second squared, so 80 times 10 will be 800 newton, and that is the weight of the man. when the elevator is stationary. The scale will record this weight. Also, in the second one, they say when the elevator moves with a uniform speed, the weight will not change. It will still be same as what you have when it is at rest. Because look at the material here. They say when the elevator is at rest or moves with a constant velocity. So that value of the velocity is not even important. You are not going to use it in the calculation. Look, this 20. Ignore it and use the same thing. That's why we say weight equals mg again and equals 80 by 10, and that is 800 Newton again. Thirdly, when as C said, when it ascends, okay, I'm sorry, the C should not be here. This is S and then C. It's a typing error. Ascends with acceleration 5 meters per second square. Okay, when it ascends with acceleration, and that's the second one. They say when the leaf accelerates upwards, what do you have? Your weight is greater than the true weight and is m into a plus g or g plus a. So we are going to use that to get it. So when it is ascending, our weight is m into g plus a, and m is the mass 80, g acceleration due to gravity 10, a is the upward acceleration 5, and look at what we are given. The upward acceleration 5 meters per second squared. So when you put it, just press your calculator, use your calculator, 80 into 80 open bracket 10 plus 5 close bracket, and press equality sign. You will get 1200 Newton. That is the weight of the man, and you can see this weight is greater than the true weight of the man. The true weight of the man is only 800 Newton, but when the elevator is moving upward, it increases to 1200, which means it increases by 400 Newton. Okay, next they say when the elevator descends with acceleration 4 meters per second. So if you go back to the material, when the elevator is descending, the formula is m into g minus a. So you take that formula, you use it here. When you use the formula, look at it, weight equals m into g minus a, and then you have mass as 80 and g is 10 minus, then downward acceleration is 4. So press your calculator, 80 into open bracket 10 minus 4 close bracket, and this will give you 480. You see that the true weight of the man is 800, but because now the elevator is descending, it reduces to 480. You see, and this makes sense. It really makes sense. It agrees with the principle. Finally, uh, when the elevator is falling freely under gravity, it should have zero acceleration because A equals G here. So again, look at this one. Falls freely under gravity. That's the last one, E. So your weight is equal to M into G minus A. But my A is also G, so it should be G minus G. G minus G will be 0, and 0 times mass will be 0, so my weight will be 0. Thank you for watching. Let's meet on the 11th video.